Some 13.75 billion years back, our universe sprang to life in a brilliant burst of creation. In the immediate aftermath, the earliest light began slicing through the darkness, illuminating the newborn universe as it started to swell in size. This rapid growth initially slowed a bit after its fiery start, but oddly enough, it's been picking up speed over time, thanks to the growing presence of dark energy. This trend suggests the universe has been on a constant acceleration since it first came into being. For hundreds of years, the curious minds of physicists and mathematicians have been probing the mysteries of the universe, striving to unlock the secrets it contains. But there's a brave bunch of scientists who take it a step further, pondering what might exist beyond the edge of our cosmic neighborhood. Is it possible there's more out there, other universes or dimensions, perhaps, that we can only guess at? This isn't just wild speculation. There are actually 5 theories out there, each offering clues to these enigmatic possibilities. If this cosmic journey fascinates you and you're keen to dive deeper into these theories, remember to give us a thumbs up. Make sure you're subscribed to Cosmic Code to keep up with all the incredible stories we'll be bringing you about the universe's wonders. This story is more than just a compilation of facts, it's a call to adventure, a collective quest for knowledge. We're here to make the complexities of the cosmos understandable and intriguing, reaching out to folks of all ages, from teenagers to those in their golden years. So, let's embark on this journey of exploration together, nurturing our collective awe and curiosity about what lies beyond the stars. Talking about what's outside the universe is pretty complex, mainly because getting a handle on what we mean by the universe isn't straightforward. A term that gets thrown around a lot is the observable universe. This term is handy because it considers the speed of light as a limit. Since we can only see objects if the light they emit or bounce off reaches us, our sight lines are capped at the farthest point light has traveled since the universe began. Scientists reckon the oldest light we can see has made a whopping journey of 45 to 47 billion light years since the Big Bang. This means the observable universe stretches across about 93 billion light years. Imagine that every little particle, every blazing star, and every mysterious black hole we've spotted, plus all the wonders we haven't yet seen, are within this mind-boggling distance. But here's the kicker, the observable universe is all about the light that's had the chance to reach us. As more light from distant parts of the universe arrives, this observable zone gets bigger. Yet, in another sense, the universe is finite, bounded by something called the Hubble volume. Named after the telescope that's given us a peek at the furthest corners of the cosmos, the Hubble volume marks the edge of what we can hope to see. This boundary isn't just some theoretical line in the cosmic sand, it's the practical limit of our universe as we can know it. Beyond it, the universe might stretch on, but it's out of our reach and understanding. So, we're left with a universe that's unfathomably large yet intimately tied to the journey of light that has managed to reach us, expanding the scope of our known universe but also setting its boundaries. This blend of boundlessness and limitation is part of what makes the cosmos so endlessly fascinating, pushing us to ponder the vast unknown that lies beyond our sight. The idea that our universe stretches infinitely beyond what we can see ignites the curiosity of astronomers and cosmologists. The vast, unseen expanse might be filled with endless matter, energy, and galaxies, arranged similarly to what we observe around us. Picture moving past the Hubble volume's edge. It's not merely about discovering new planets, but finding worlds that mirror our Earth in uncanny ways. Journey far enough, and you could find a solar system with an Earth so alike ours it's startling, right down to your choice of breakfast this morning. In one version of reality, you chose cereal instead of eggs, in another, breakfast was skipped, and in a different twist, the day began with a bank heist. The thought that traveling far beyond the known edges of our universe could lead us to a Hubble volume, mirroring our own, opens the door to infinite possibilities. Here, alternate versions of us live out every scenario imaginable, embodying the vast array of choices we face. Though this pushes the limits of what seems believable, the concept of an infinite universe challenges our understanding. According to the theory of relativity, while objects close to each other can't exceed the speed of light in their movement relative to one another, this restriction falls away for objects far apart thanks to the universe's expansion. Thus, it's not about moving through space faster than light, it's about the expansion of space itself. Therefore, reaching the outer bounds of the observable universe presents significant obstacles. Achieving this would require transportation methods that either outpace light, a concept most physicists find unlikely, or manipulate the structure of spacetime via wormholes or warp drives, ideas that remain on the fringes of scientific speculation. The universe, with its infinite possibilities and profound mysteries, continues to fuel our wonder and provoke debate. It presents a vision of limitless worlds and alternate versions of ourselves, engaging our imagination and driving our quest to decode the cosmos. Back in 2008, astronomers encountered a baffling surprise. They observed galaxy clusters hurtling together in a unified direction at speeds topping 2 million miles per hour. This mysterious movement, which was further confirmed by observations in 2010, earned the moniker dark flow. This phenomenon was unearthed through the examination of some of the most massive structures in the universe. Researchers, analyzing data from these enormous clusters, pinpointed a consistent pattern of motion, indicating a collective flow spanning the cosmic expanse. This discovery was particularly fascinating as it suggested the presence of unseen forces or structures exerting influence over galactic movements on a scale far beyond what was previously considered. The dark flow poses a significant challenge to our conventional understanding of the cosmos. Current cosmological frameworks, like the lambda cold dark matter lambda CDM model, assume that after the Big Bang, matter should be distributed fairly evenly on the largest scales, resulting in galaxies and their clusters moving in varied directions due to the universe's initial conditions and gravitational forces. However, the dark flow implies the existence of unseen influences shaping the trajectory of these gargantuan structures. To explain the dark flow, various hypotheses have been put forth. One suggests it could be due to gravitational pulls from massive concentrations of matter lying beyond the edge of the observable universe, hinting at our universe being just a fragment of a much larger cosmic tapestry. Another posits that the flow could be influenced by cosmic textures or anomalies in space-time fabric from the universe's infancy, pulling galaxy clusters in a specific direction. The revelation of the dark flow has sparked new lines of inquiry and discussion among astrophysicists, underscoring the inadequacies of existing models and opening the door to potential new theories or physics to elucidate the motion observed in galaxies. As research into this enigmatic phenomenon progresses, the dark flow stands as a compelling enigma on the frontier of cosmic exploration, reminding us of the vast unknowns that await discovery in the universe. Huge gatherings of galaxies, known as giant galaxy clusters, enveloped in scorching gas that radiates X-rays, act as astronomical research hubs. Scientists can investigate the motion of these clusters by studying the interaction between X-rays and the cosmic microwave background, CMB, radiation, the Big Bang's residual heat, This interaction redistributes photons across the CMB, modifying its temperature in a process referred to as the Sunyaev-Zeldovich (SZ) kinetic effect. While this phenomenon was anticipated in theory, its actual observation linked to galaxy cluster movement was achieved by Alexander Kashlinsky's team at NASA's Goddard Space Flight Center. This insight was derived from analyzing approximately 700 clusters, some located as far as 6 billion light-years away, practically half the universe's span, by comparing them against the CMB map produced by NASA's Wilkinson Microwave Anisotropy Probe (WMAP) satellite. The observed movements of these clusters challenged the previously held beliefs regarding the distribution of mass in the universe post-Big Bang, suggesting the influence of enormous, unseen structures exerting gravitational forces beyond the Hubble volume. Such a revelation implies that our universe's structure is not as uniform as once thought, especially at larger scales beyond our observational reach. The exact nature of these massive entities remains speculative, with possibilities ranging from immense accumulations of matter and energy to strange gravitational quirks potentially connected to other universes. This finding significantly impacts our comprehension of the universe, suggesting the presence of cosmic structures far larger than any we've directly observed. It challenges the conventional cosmological view that posits a uniform matter distribution on the grandest scales. As researchers continue to explore the enigma of these vast galaxy clusters and their unusual movements, we inch closer to understanding the universe's true expanse and structure, pushing past the boundaries of what we can see. The infinity bubbles concept introduces an enthralling view on the cosmos's structure, hinting that beyond the Hubble volume, yet within the same vast universe, things might operate quite differently than we've assumed. This idea, rooted in theoretical physics and cosmology, suggests that the post-Big Bang expansion could have spawned various bubbles within the space fabric. Each bubble, having stopped expanding along with the rest of space, potentially houses its own universe, governed by its own set of laws and constants. Imagine space as not just infinite, but as a host to an endless number of these universe bubbles. This notion that one infinity can contain myriad others underscores the universe's boundless nature, indicating that each bubble universe could itself be infinite. Yet, this concept raises a puzzle: the gap between these bubbles. Even if crossing one bubble's boundary were possible, the ever-expanding space outside would prevent reaching another bubble. The space between these universes expands more rapidly than any possible speed of travel, leaving each bubble universe in splendid isolation. This theory significantly broadens our understanding of the cosmos, positing a potentially infinite expanse beyond what we can see, filled with distinct, unreachable universes. The infinity bubbles theory enriches the multiverse theory, challenging us to contemplate the cosmos's true nature and the potential existence of countless realities beyond our own. It showcases the universe's immense scale and complexity, stretching the limits of both our imagination and scientific exploration. The journey through the cosmos continually pushes the limits of our imagination, taking us into the depths of theories and ideas that extend well beyond what we can see and measure. Among the most enthralling concepts are those revolving around the mysteries of black holes, the potential existence of parallel universes, and the underlying forces that shape our universe. Lee Smolin, a forward-thinking physicist, brought to light the theory of fertile universes, suggesting an intriguing possibility that each black hole could be the cradle for a brand new universe, each governed by its own set of physical laws, slightly different from those of its parent universe. This concept introduced a Darwinian element into the cosmic equation, positing that universes proficient in generating black holes, and thereby more universes, might multiply, while those lacking this capability might gradually fade away. It's noteworthy, however, that Smolin and others have since revisited and critiqued this theory, illustrating the adaptive and evolving nature of scientific exploration. The notion of parallel universes further broadens our understanding of reality, with various theories postulating their existence. One particularly compelling theory emerges from the advancements in string theory, suggesting the presence of oscillating membranes or branes in dimensions that elude our direct observation. These vibrating membranes, dwelling in the 11th dimension, are thought to create entirely separate universes. The interaction or collision of these dimensional ripples could lead to the birth of new universes, potentially explaining the distribution of matter observed in our own universe. An intriguing aspect of this theory is its attempt to explain the relative weakness of gravity in our universe compared to the other fundamental forces. It proposes that the gravity we experience might actually bleed into our universe from another, existing in a different dimension. This novel perspective on gravity offers a potential explanation for its seemingly diminished strength in our cosmic realm. These theories beckon us to contemplate the existence of undiscovered realms beyond our universe, challenging our perceptions of infinity and the fabric of reality itself. They prompt us to question the very nature of the cosmos. Is it a singular, vast expanse, or a complex web of interconnected, parallel universes, each pulsating to the rhythm of its unique laws and constants? What do you think about these deep cosmic questions? Are these theories merely flights of fancy, or do they provide real insights into the universe's mysteries? Share your thoughts and engage in the dialogue about the boundless possibilities waiting just beyond the edge of our known universe. If you liked this video and want to continue exploring the world of science and nature, don't forget to subscribe to the channel and turn on notifications so you don't miss any future content. Until the next adventure.